In this lecture we will show how to use primitive data types in Rust. We have 4 different primitive data types in Rust, and these are floats, integers, characters and booleans. We will start with booleans here. We have here empty project that is created using cargo as it was shown last time. I will now define the first variable. To begin defining any variable, you start with keyword let. After that you have the variable name. Then after the column you have the variable type, and last, after the equal sign, we have the expression that is assigned to this variable. Here we have just a constant expression true. Bool variables can only have 2 distinctive values, and these are true or false. Also, if Rust can infer type from expression, then we can omit the variable type here. Now we can try to change the value of this variable, and we see that Rust immediately complains, and this is because when you define any variable, it's by default immutable. That means that it cannot be changed. So if you want to change this to mutable variable, you must add the mut keyword before the variable name, and now everything works correctly. Bool variables in memory takes 1 byte of storage. Next we will define the integer variable. So it's very similar as for the bool. Here we specify the data type of integer. So this is a 32-bit unsigned number. Rust also supports signed numbers, so we can change this prefix. So now it's signed number, and also this is the default type for integers. Rust has many different integer types. I will now list all of them here so that you can see. So yeah, on the left side we see types in the Rust, and on the right side we see bit size of each type. The last two are pointer dependent types. That means that their size depend on the target machine. So in total we have 12 different integer types in Rust. Next we can define floating point variable. Okay. So we have 2 different floating point variables, 32-bit and 64-bit. Here is 32-bit, we can change to 64-bit. And yeah, also we can omit a type if you like, because default type is 64-bit variable. Next, I will show you how you can convert between different data types, because this is something that you will need to do very often. So first we will insert a snippet of code. Here we define some variables, and now we can try some conversions. Here we try to convert a bool variable to unsigned integer, and we see that Rust complains, and that is because he doesn't allow implicit conversion, and everything must be done explicitly. To do explicit conversion, we use as keyword, and you specify type of conversion. Okay, now Rust can infer type of this expression, so we can omit this specifying type on the left side. We can run the program. In previous lecture I ran program going to terminal and using cargo run, but these extensions that I installed on Visual Studio Code allow me to run program directly from here, so it's much faster. We got 1 as a result of our program, and this is as expected, because for bool variable true converts to 1 and false converts to 0. Also, some conversions are forbidden in Rust. For example, if we go directly to 60-bit float, Rust complaints, and he tell us that we go first, that we first convert to integer and then we go to floating point. Okay. Next we can try to convert this bigger integer to smaller integer. And run the program. We got 50 and this is as expected. Next, the problem is when you have some integer that have a bigger value that doesn't fit in the smaller integer like this. So this on the right side we see how this number is represented in memory, and this 38 is lower byte and this 10 is upper byte. So when you are doing conversion like this, only the lower part will be taken. So I expect 38 to be the result of this conversion, and we can now check this. Yeah, we got the real 38 as expected. So for the floating point numbers, there are different rules. So if this number is in the range that this integer can represent, then only this fraction part will be removed. So we can try this. And we got 65 as expected. But if we have some number that is outside the range that this integer can represent, then it will be converted to the smallest or the maximum value of this integer. So in this example I expect to get the 0 for negative values, and if you have some bigger number, then I expect the maximum value that the integer can represent, and that is 255. Primitive types in Rust also looks like some kind of objects, because we can call methods of them. For example, if we write some floating point literal, we can call, for example, a sinus function on them. Here Rust complains because he doesn't know if this is 32 or 64 bit, so we can add the suffix to change the literal type, and now everything works. You can change, you can add this suffix on any literal type. For example, for this statement, to get the same effect, you can change a literal type here, and then you can omit specifying type on the left side, and you get the same effect. You can also chain multiple methods call easily. For example, first we want to convert this to radians and then call the sinus. So we'll just add first call to radians. And then we can call the sinus. So it's very easy to chain multiple methods. Okay, we can run this. Also, as I said, you can call many methods on primitive types, and you can see the list of the methods that we can call. It's a big list. Some of these methods will be explained in the next lectures. Here, for example, we can convert between the big Indian and little Indian. Or, for example, you can calculate the minimum between two values, and you just specify another value here, and you run program. Yeah, I see that 44 is lower, so it's written. Also, using methods, we can also convert, do conversion between some types. For example, now we want this boolean variable to convert to floating point. We can call the method into, and when you are doing this way, then you must specify type on the left side, because Rust will doesn't know in which type you want to convert this boolean variable. Next, I will show you how to do basic mathematical operations. So I will paste a small snippet of code. Here we define two unsigned integers, And here we have all these basic mathematical operations like addition, subtraction, multiplication, division, and remainder. We can now run this program and see the results of these operations. If you have some more complicated expression, then you must be very careful about precedence of operator. So here first is done multiplication, then addition. If we want to change order of this operation, we can put in parentheses. So now first is done this addition, then multiplication. Also, you must be very careful about overflow. So I will just delete and show you on multiplication. So if we increase the value of these integers, and now if you multiply these two values together, you will get some large integer that cannot fit into this 60-bit integer. I can try to run this program. We see that Rust detects this and throw us an error. So how we can deal this in a couple of ways. So first, of course, you can increase the size of the integer and use 32 or 64-bit integer. But some functions rely on this modular arithmetic. So there is another way how we can do this. So we can call this wrapping function. We have for all the operations. And now we can call this for multiplication. And here, yeah, and run the program. And now we get the expected result. Next, I will show you bitwise operations. So first I will just delete this code and copy paste new snippet of code. Okay, here we define just two integer variables. Then we have the bitwise operations. So first we have this bitwise AND operator, then we have this bitwise OR, then we have this exclusive OR. The next two are left and right shift operators, and the last one is not operator. And here we just print the results from these operations. So I will just now run the program, and we can see the results from these operations. Now I will show you the comparison operators. First I will just delete this piece of code and paste another one. So here we just define two integer variables, then we have this list of the expression that uses this comparison operators. Results from these operations are booleans variables. Here we have this equal operator, then we have not equal operator, then less than operator, greater than, less than or equal, and the last is greater than or equal. Here we just print the results from these operations. So I'll just run the program, and here we see the output from these operations. Now I will show you the logical operators. So first I will just delete this and write another snippet. Here, logical operators are only defined on the boolean variables. So here we define two boolean variables, and then we have this expression using this logical operators. So we have logical not here, then we have logical and logical or. We print just the results here. These boolean variables also support bitwise operations. So here we have bitwise and bitwise or, and also just print the output. So now I will just run the program so we can see the output from all these operations. Last thing that I want to show you are these compound assignment operators. So I will enter another snippet of code. So here we just define one mutable variable, And then we have this compound assignment operator. So this is the addition. Then we have left bitwise operator and bitwise AND operation. These are just few of them. Many of the previously shown operators support this kind of compound assignment. So I'll just now run the program so you can see the results from these operations. And that's all about primitive types in this lecture. Character primitive type will be shown in lecture with strings. See you in next lecture. Bye.